So one important advantage of the concept of present value is that all cash flows can be translated in the same unit, which is what does it mean in terms of cash today, right? So present values can thus be added, subtracted, compared, and different things because they are all in the same unit. So let's just take a look at one example to understand this point. So imagine that you have a project that generates 10 in 1 year's time and 8 in 5 years' time, right? So, because these are payments that are kind of like in different time periods, you cannot simply add up the two, right? Because 10 in 1 year's time is not the equivalent to 10 in 5 years' time. And so, therefore, you cannot just add up 10 plus 8 to get a value of 18, right? So, you cannot add future values at different points in time. However, if you do translate both this 10 in 1 year's time and 8 in 5 years' time in terms of money today, then you can indeed go ahead and add them, right? So this would suggest the following procedure. So first, we need to calculate the present value of 10 in 1 year's time and the present value of 8 in 5 years' time. How would we do that? Well, we can use the general formula for present value. So this says that suppose you have a cash flow of CT in T time periods, and the per year interest rate is R, then the present value of this cash flow in T periods ahead is going to be given by CT divided by 1 plus R to the power T, right? So let's take this particular example that we had and suppose that the interest rate is 5% per annum, right? Then the present value of 10 in 1 year's time is going to be equal to 10 divided by 1.05 or 9.52 in today's units, right? And the present value of 8 in 5 years is the equivalent to 8 divided by 1.05 to the power 5, which is rounded off to 6.27 in terms of today's money. So again, how are we getting this? So C5 is basically 8, and then you have got 1.05 to the power 5, right? And once you have these in today's terms, because they are now in the same unit, you can add them up. And so that means that the total value of the project's cash flows, which are 10 in 1 year's time and 8 in 5 years' time, in today's term is basically 9.52 plus 6.27 or 15.79, right? So then again, that's the advantage that we are doing. We are converting everything into today's terms and then we are adding them up, which is a valid operation. Okay. So once we have this concept of present value, we can use it to think about what is a net present value of an investment. So this is basically nothing but the present value of all its future cash flows minus the present value of its cost, right? So the word net is there nothing but to kind of remind you that you need to add and subtract all cash flows, including whatever is upfront investment cost. Okay. So the NPV calculation method is the following algorithm. So first translate all future cash flows into today's units, then add them all up. This gives you the present value of all the future cash flows. And then whatever is the initial cost that you are incurring this period, you should subtract from this present value of all future cash flows to get the NPV, right? So this is actually perhaps the most important method for determining the value of projects, right? So let's take a example. Suppose that you have to pay 12 units today for the project that we just discussed, which is going to pay out 10 units 1 year later and 8 units in 5 years' time. The rate of interest is 5% per annum. So what's the NPV of this project? So if you want to calculate that, so first step, remember, is that translate all future cash flows into today's unit. So 10 units 1 years in the future is going to be given by the present value is 10 divided by 1.05. 8 units in 5 years' time, the present value of that is 8 divided by 1.05 to the power 5. And this is this first two terms, the sum of that is basically the present value of all the future cash flows. From this, you need to subtract what is the cost upfront today, so minus 12. And now if you do the calculation, this is approximately 3.79, right? So this is basically saying that this project that you have is a positive NPV project. And as we'll see later, then this would imply that, this is a project that one should indeed take up, right? So before we get into that, let's just think about what is the interpretation of this NPV being 3.79, right? So there are multiple ways of thinking about this. Let's look at these different ways so as to think about, why do we have the NPV rule in the way that we have it, right? So one interpretation is you can think of 3.79 as the difference between the market value of the future cash flows and the project's cost, right? So what this means is that this difference, which is the NPV, is nothing but the value added. Since the value added is positive, hence it makes sense to take up this project. If on the other hand, the value added was negative, which would have been the case, for instance, if this upfront cost was, let's say, 20, then it would not have made sense to take up the project, right? There is a second way of thinking about NPV, which involves a few more calculations, but I think kind of like sheds a bit more light on what this concept tells us. So the NPV actually tells us about how a project that you have compares to the alternative opportunities of investing your money in the capital market. So one option is this 12 units of money that you had invested in this project. And as a result, you would have ended up getting 10 units 1 year later and 8 units of money in 5 years' time, right? The alternative is that instead of investing it in the project, why don't you invest it in the capital market at the rate that is prevailing? So that's 5%. So then this 12 units, if you invest it in something which gives you 5% every year. So let's think about it. So this 12 units would grow into 12 multiplied by 1.05 or 12.60 next year, right? Now, I want to compare how it does compared to this project, right? So suppose I wanted to take out 10 units 1 year later. So out of this 12.60 units, can I take out 10 units? Yes, because I have more money than that. So then I can take that out. And this 2.60 units that I have left over, I should just invest it again back in the capital market at a rate of 5%, right? So if I do that, so 4 years later, which means 5 years from today, it's going to basically grow into 2.60 multiplied by 1.05 to the power 4, right? And this is basically 3.16 units 4 years later. But notice, if you had invested money in the project, you would have got the same 10 units 1 year later. But instead of 3.16 that you are getting 4 years after that, you would have got actually 8 units 4 years after that, right? So therefore, the project is kind of like able to give you better returns compared to what you would have got if you had invested your money in the alternative, like in the capital market, right? And hence, in that way, you get an intuition why this project is better than actually just investing it in the capital market. Okay. So what's the general formula for the NPV? So this is given by C0 is, let's say, the cash flow. And we are going to think of a cost as a negative cash flow. So that's why you had seen the formula as minus C0. But here, let's suppose C0 is the cash flow. Suppose C1 is the cash flow in time period 1, C2 is the cash flow in time period 2, and so on. So some of these can be 0. That's perfectly fine. So NPV is basically the addition of all the present value of this, right? The present value of C0 is just C0 because C0 is already in today's terms. Present value of C1, present value of C2, and so on, right? Now, if we want to write it in terms of 1 year return, 2 year return, we can do that. So C0 in today's term is C0. Present value of C1 is C1 divided by 1 plus R1, where R1 is the 1 year return, plus C2 divided by 1 plus R2, where R2 is the 2 year return, and so on, right? And we can translate this in terms of the per year return as well. If this per year return is constant, for example, so then 1 plus R1 is just 1 plus R, 1 plus R2 is 1 plus R whole square, and so on, right? So this is a formula that you should actually memorize, right? But hopefully you also now understand where it is coming from. And so therefore you can derive it yourself. Okay. What does the NPV capital budgeting rule state? So it states that one should accept those projects which have a positive NPV and reject those projects which have a negative NPV. And if the NPV of a project is 0, then one is indifferent between accepting or rejecting, right? So let's take a example to see how this works out. So imagine that you have a project which costs 900 units today, and it's going to yield 200 units per year for 2 years starting from year 1. And then after that, it's going to yield 400 units per year for the next 2 years. And finally, the 5th year, it's going to require a cleanup expense of 100 wrap up things, right? So think of this as perhaps a kind of like a mining operation, right? Where initially you have to put in some money, and then over some time it's going to give you back some money, and finally you have to clean up the mine to conclude the operation. So again, there is a cost at the end, right? So imagine that the interest rate is 5% per year. Should one take up the project, right? So in order to answer this, you have to first calculate the NPV of the project. So you can use the formula that we have just stated here, right? So C0 is going to be minus 900 because this is a cost and hence it's a negative amount. And then after that, in year 1 and year 2, you're going to get 200. So if you discount that, then the present value becomes 200 divided by 1.05 plus 200 divided by 1.05 square. Okay. Then the next 2 years you get 400. So in year 3 you get 400. So you again discount it so as to get 400 by 1.05 cube plus 400 by 1.05 to the power 4. And finally in year 5 you have to incur again a cost of 100 to wrap up this project. So then that is a minus 100 divided by 1.05 to the power 5, right? Now you can calculate this again using Excel or using your calculator. And then this will basically become 68.15, right? So since the NPV is positive, then you get the answer that one should actually indeed end up taking this project. Okay. Let's look at like another application of NPV, and this will be a very kind of like I think a surprising answer, right? Okay, so you can actually apply NPV to think about in terms of investment in companies as well. So one question is, for instance, does it make more sense to invest in companies that are going quickly rather than slowly, right? Let's just put some numbers. So suppose that you have two companies, company grow and company shrink. So we are going to call company grow as G, company shrink as S, and they're only going to be in operation for the next 3 years, right? So G is going to have a cash flow of 100 in year 1, cash flow of 150 in year 2, and 250 in year 3. So you can clearly see it's growing. Whereas shrink is going to have a cash flow of 100 as well. However, in year 2, it's going to have a cash flow of 90, and year 3, it's going to have a cash flow of 80. So you can see that the cash flow is actually slowing down, right? There is no uncertainty involved. So we know these cash flows are going to happen for sure. And both of these companies are going to stop their operations from after period 3. Okay. Suppose that both firms face the same cost of capital of 10%, which means that the interest rate is basically 10% for them. And then the question is G a better company to buy compared to S, right? So one might kind of like think at first glance, then the answer should definitely be yes, right? Because one is thinking that, one firm is growing, the other firm is kind of like shrinking. So this seems a no-brainer, right? But I encourage you to kind of, before concluding, to pause this video and just think about the answer for a bit. Okay, to actually answer this question, what you need to think about is what's the price at which these companies can be bought, right? So that's one question, but that's only an intermediate step in answering your question, right? So let's think about it. So what is the price of company G today? So that's nothing but the present value of getting this cash flows in the future, right? So given the rate of interest of 10% per annum, the present value of 100 in year 1, 150 in year 2, and 250 in year 3 is going to be given by this formula. So 100 divided by 1.10, 150 divided by 1.10 to the power 2, 250 divided by 1.1 to the power 3. This is the thing by the present value, right? And if you do this calculation, this is approximately equal to 402.70. Similarly, you can kind of like do the same calculation for the price of company S. So this should be present value of S, not G. And if you do the calculation, this is going to be 100 divided by 1.10 plus 90 divided by 1.1 square plus 80 divided by 1.1 cube, right? And this is approximately equal to 225.39. Again, this should be present value of S. So what you get is, because the company G is growing, that should have a higher present value and therefore higher price. And whereas since the company S is slowing down, that you can see is translating into a lower price today, right? So clearly, what you get from here is that already a first hint of something more going on, right? Because when we are actually thinking about which company to buy, we also definitely need to also think about what is the price, right? We just don't look at only what is going to be the future cash flows. We should think of also what's the price, right? And so therefore, the relevant thing to think about when you are thinking about a company is what's the return that you're going to get if you invest, right? Rather than thinking about, okay, these are the cash flows and these are the prices. How do you kind of like put them together? You look at the returns, right? So let us look at that. So what's the rate of return from this year to next year? If you put your money in company G versus if you put your money in company S, right? So let's first do, if you invest in G, so what will happen? So next year you are going to have 100 units of cash, right? Because this was the cash flow. And then you are going to own a company which has 150 units of cash flow coming up in 1 year and 250 units coming up in the next year, right? So from period one's perspective, company G's value is going to be given as the following. So you have got 100, which has come out, plus 150 that's going to come out the next year. So you discount it by 1.1. And then the next year after that, you have got 250 coming up. So again, to calculate the present value, you divide it by 1.1 square, right? So this becomes basically 442.98. So what this means is that if you had purchased the company at a price of 402.70 today, you are going to have something which is valued at 442.98 1 year down the line. And so therefore, you can calculate the rate of return from this company, and that's approximately 10%, right? Okay. You can do the same thing for company S. So if you invest in company S, then next year you are going to have basically 100 units of cash, and you are going to own a company which is going to pay out 90 units the year after and 80 units the year after that, right? So again, S's value at time one can be calculated as 100 plus 90 divided by 1.1, because this is going to come up 1 year in the future, plus 80 divided by 1.1 square, because 80 is going to come up 2 years from time period one, right? So this is going to become 247.93 approximately. So basically an investment of something at a cost of 225.39 is going to yield something which is worth basically 247.93 in the future. And again, if you kind of like do the calculation, you can show that this is also 10%, right? So what you end up is getting is that both of them are going to have a return of 10%. And basically the lesson that you should take away from this is that you should not be kind of like distracted by the fact that one company is growing slower versus the other company is growing much faster. Once you are thinking about buying those things, the prices are going to be important factors as well. And the prices, in some sense, already would be reflecting in the perfect market world that we are studying, the prices that are there in the future, right? So as a result of that, the company that is expected to grow faster would already have a higher price, and hence the rate of return would actually end up being the same for both of these companies, right? And so the answer, surprisingly, is that actually neither is a better deal, and both of them give you the equivalent rate of return, right? So I think this is like one of the value addition of kind of like thinking about how to apply this concept of NPV much more systematically, so that you get some answers which are actually counterintuitive.